Okay, so just say we're going to talk about ellipses. You have known them in the past as ovals in middle school and elementary school, but the proper name is ellipse. So from now on, you're called ovals, ellipses, now that you know their name. Okay, side note, a perfect ellipse is a circle. So a circle actually falls underneath the category of ellipse. Okay, some ellipses or ovals called elongated circles. You might have heard that before too. You stretched out a circle, and that's quote oval, but the real name is ellipse. All right, so here's our standard form. They're calling it standard form again. What do you call it? Standard form, or quote in a way vertex form, even though it's technically not a vertex. You see it very similar to a circle, but notice on both of these, it's equal to 1. Okay, so I have to make it equal to 1. If the number wasn't 1 there, I have to divide both sides by whatever number is here to make it a 1, just so you know that. Second off, oops, I don't know why I did that. Okay, second off, you notice it's still x minus h quantity squared and y minus k quantity squared. You've seen that over and over. H comma k is quote the center. Okay, and so that's still true, as you see right here for the center. Orientation, as opposed to in geometry, when we talk about orientation, it was clockwise or counterclockwise. Well, this is horizontal, so is the elongated part horizontal or is the elongated part vertical? So is it stretched horizontally or is it stretched vertically? That's what orientation means in regards to ellipses. So how you know is if they give you the equation by this setup, the larger number in the denominator here is going to be a, and b is going to be the smaller one. B squared, a squared is the larger one, b squared is the smaller one. So a squared always goes whatever the larger number is on the bottom. That's going to be the first one, and the smaller one is going to be the second one if you put it in this order. So notice even under when I switch the order, so this is saying that what was the larger number of a squared and b squared was a squared. Whatever that number was, that's under y in this case. So we switch and we put y first. In this case, x had the larger number at the bottom, so x goes first. And that's, I mean, you really, it doesn't matter. The key is to help you graph it. You're just knowing that the larger number is going to be whatever that is underneath. So it's underneath the x. It's going to be stretched horizontally versus if it's under the y, it's stretched vertically. Okay. Um, it's not drastically, you know that to graph it because you do the same rules regardless on graphing. Now to get C, okay, so we have also within that, not only do you have a center, we have foci. Just like you have the foci in the parabola, well, now you also have foci. You have a focus in a parabola. It's singular. Foci is plural. That's how you say that, foci, for plural. You have 2 of those, and they're always inside the ellipse, never outside for an ellipse. Okay. The center will be directly in the middle of those 2 foci. So right there, there's a center. I can tell you right there, because the center is always the midpoint of the 2 foci. Just so you know that. So if they gave you the foci to begin with, for some reason, you just take the midpoint of that, and there's your center. Now remember, when I write my equation, the x minus h squared and y minus k squared, there's my center right there. So it would tell me how to write that. So since that point is negative 2, 3, this has to be x plus 2 quantity squared and a y minus 3 quantity squared equals the 1. Okay, already. Just from knowing that center right there, negative 2, 3. Okay, now here's one thing to note. C squared equals a squared minus b squared. Remember, Pythagorean theorem is a squared plus b squared. Okay, well, with the ellipses, you subtract the 2. A squared minus b squared. A squared has to be a larger number because you can't get a negative distance. You get an imaginary number when you take the square root, find c. So the larger number always has to be first. Okay, so the larger number is always your a squared. So a squared minus b squared equals c squared, and then take the square root of that, and that will give you c. That is how far out you go to get the two foci. So 1, 2, 3. That distance is 3. So that means c equals 3 here. Okay? Just so I know that. Okay? So then c squared is 9. Okay? So I know c squared is 9. So a squared minus b squared, that has to equal 9, wherever it is here. Okay? Now, notice how the foci are inside. If it's horizontal, they're both inside it. But you're adding it, if you're going vertically, as we do here on this particular example here, you're adding it and subtracting it from the y coordinate because it's going up and down from the y coordinate. So that's why you see the c adding and subtracting from the y coordinate k. Remember, k is the y coordinate of the vertex. If it was horizontal, you're adding or subtracting it from the the x coordinate, and the x coordinate is the h value. That's why you see that there. Now you also have vertices. And here's what really deals with for plotting it. It's your starting from your center. You already have h comma k. You go out a, which is the square root of that number. Okay. You go out the square root of that number, a, in the x direction. So this is right underneath the x, and you go out the square root of b, or the square root of b squared, which is b, in the y direction, top, up and down. And then you get 4 points. This vertex is called the vertices. Okay, so these are the 4 vertices right here. They always go out from the center, horizontally and vertically. Okay, now of course the longer one from here to here is longer than it is from here to here. So the longer one, the whole length, that's called the major axis. We go back up here and look up here, major and minor axis. The major axis is just the longer segment. The smaller segment is called the minor axis. So that's the minor axis right there. Okay. So now you understand major and minor axis. But the way c is related, you gotta remember c squared equals a squared minus b squared. Okay. The length of the major axis is 2a, because again, from here to here is a. We went out a in each direction, so obviously the whole length is 2a. And we went out b in each direction here, so the whole length is 2b. Okay, so that should make sense. So the length of the major and minor, 2a and 2b. Okay, so you see here, that doesn't change. Okay, so now let's go ahead and look at this problem right here. Write an equation for the ellipse. The length of the major axis is the distance between -2, this point right here, and -2, 8. So from -2, 8 to -2, -2. How far is it therefore from -2 to 8? A total distance of 10. So 2a equals 10, and so a equals 5. Okay, well a is 5. Well, don't forget what goes underneath here is a squared. So what's 5 squared? 25. Okay, well how far is it from b? Or what is b? 1, 2, 3, 4. There's b, and we want b squared. 4 squared is 16. So there's our equation right there, where that was equal to 1. Okay, we have our center, -2, 3. There's our center. It always equals 1 at the end. We calculated out what a was. That's 5. 5 squared is 25. Hold on here. So I wrote this wrong. Notice a is going in the y direction, right? Up and down. So 25 is actually right here underneath the y. And 16 is underneath the x. 16 is the left and right direction. Okay. So this is your answer right here. Now, they would like you to put, since a squared, since this 25 is bigger, they'd want you to put the y squared first. Okay, it technically doesn't matter. You're going to graph the same thing in addition. Remember, it's a plus sign in between here anyway. So addition is commutative. I can switch the order. So if we look down here at their answer, notice they put the y first because that's the major axis and that's the minor axis. It doesn't matter. What I wrote there, if I switch this whole thing, put that there and that there, it's still the same. Can't get marked wrong. The key is I put the right number. Since I'm going vertically here, I'm talking vertically there. Then I square that. That goes into the vertical one, which is the y coordinate. When I count it horizontally, that's in the x direction. I square that. That goes underneath the x coordinate. That's the key that you have to remember. Okay, not necessarily, oh, I have to have the y first and the x second. Now, when it comes to hyperbolas next, since it will be a subtraction sign, then subtraction number matters. 1 minus 2 is not the same thing as 2 minus 1. But addition, 1 plus 2 is the same as 2 plus 1. Okay. Let's see. So don't forget, you're going to have to use the key that people get messed up on this. Just so you know, the major piece is remember that to use the c squared equals a squared minus b squared. Okay. And to count out from the vertex out to the vertices. And that's going to give me my A and my B distance. I can fill in the A and the B right there then. It goes from the vertex to one of the vertices. Okay. And if I'm counting horizontally, that's under the X one. If I'm counting vertically, that's under the Y one. Okay. That's what you need to remember right here. Let's see. Yeah, there's only 5, so I'm not going to do another one. All right, let's go to the back side. Graph ellipses now. Again, they're shown both ways of switching it. It doesn't matter. The key is you know that I take the square root of that, that goes in the x direction. I take the square root of the b squared for the b, and that goes in the y direction. That's what matters. Okay, when you go to graph these. Okay, and you might have to also complete the square. Now, don't forget, in completing the square, I'm going to match my x's together and match my y's together. They don't have like that, so I have to rearrange it. That's the first thing they did. That's right there. They put the x together. I would have left the plus blank in there right away instead of going to the third step before you even do that. Okay, so just one extra line to draw, but that's fine. Don't forget, I need to factor out the coefficient of the x squared and the y squared because I can only have one x squared inside my parentheses when I complete the square. Okay, so going through that, if I was to do it, I'd have 4x squared plus 8x plus blank plus 6y squared minus 36y plus blank equals negative 34 plus blank. Now my next step is to factor out the leading coefficient for the x squared and the y squared. Take out the 4, I'm left with x squared plus 4x. Now I can go ahead and complete this square. Half of 4 is 2, squared is 4. Okay, parentheses, plus, take out the 6, I have y squared minus 6y plus, and now that blank, half of negative 6 is negative 3, squared is 9, blank equals negative 34 plus blank. Now don't forget, it's not 4, 9 that I added. That's the common error students make. Is 4 is outside here, so I have to distribute that. I really added 16 there and 54 there. What's 16 and 54? 70. Okay, so I really added 70 to the left side, so I have to add 70 to the right side. 70 minus 34 is 36. Okay, now I have 4 times the quantity x plus 2 squared, or you just drop that down there, plus 6 times the quantity y minus 3 squared, just drop that down there, equals 36. Okay, now, what do I need to remember? On the right side of my ellipse, it has to equal 1. So I have to divide every term by 36. So that equals 1 on the right side. Now it equals 1. Well, now I need to go ahead and simplify this, so this becomes x plus 2 squared over 9, because 4 cancels with 36 9 times, plus y minus 3 squared, and 6 cancels with 36 6 times. Now I have it in my standard form. Okay. And it's asking me to graph it now. Okay, so I graph it. What's the center? Let's change the color. Black. Center, as you see, is opposite, opposite. Negative 2, 3. So negative 2, 3. Let's see. I see my error. I factor out 4 right here. What's 8 divided by 4? Undo that. What is 8 divided by 4? 2. So now I have half of 2 is 1 squared is 1. So I really added 4 plus the 54 is 58. Okay. That's what I did wrong there. Okay. And this one's fine right here. Okay. So 58 minus 34 is 24. So now I'm dividing by 24 because I have 24 here. 4 goes into 24 6 times. Dang it. 6 times, and 6 goes into 24 4 times. Equals 1. Okay, so center is now, that's not a 2, that's a 1. So it's negative 1, 3, which then is right here, negative 1, 3. That is correct now. And in the x direction, I'm going square root of 6. Square root of 6 is just over 2. There's 1, 2, and a little bit more. 1, 2, 1, 2, and a little bit more. In the y direction, I'm going square root of 4, which is 2. 1, 2 right there, and 1, 2 right there. And now I have my vertices. I can draw my ellipse now from those 4 vertices. Okay, notice I didn't have to worry about getting the foci, even though if I was, the major axis is along the x. Okay, because 6 is greater than 4. Minor axis will be along the y, because that's the smaller one. It's underneath the y. Okay, I'm not having to do that. I'm just having to graph that here. Okay, so make sure you don't make my error that it didn't factor out 4. 4 into 8 is 2, not 4. I did 4 plus 4. Okay, basic error. So once in a while I do mess up. Okay. If there's nothing on 1 and 2, if there's nothing there, there's no x minus h and y minus k, you know it's 0, 0, right? So those centers are 0, 0 on 1 and 2. And you go out your distance to get your vertices from there. All right, that ends it.